Hi friends, and welcome back to Max Electronics. A couple of videos ago we've built a DigiSlate, which is a clapperboard with a built-in SMPTE timecode. And in today's video we will be building a timecode generator just like this. It works by simply outputting the timecode that can go into your camera or a slate or multiple devices. Turn it on, let it load, and off we go. So without any further ado, let's hear a quick word from my sponsor who is sponsoring this video and get right onto it. This video is sponsored by PCBWay. PCBWay is the leading manufacturer of high-quality multi-layer circuit boards with unbeatable prices. Simply upload the zip file with your project directly to the website, select your preferences, preview your board, select the postage and get an instant quote. Now you're just one click away from getting your project completed. PCBWay also offers a range of services such as PCB assembly, CNC milling, 3D printing, sheet metal fabrication and injection molding. Your project will be manufactured by highly trained professionals with a state-of-the-art equipment and delivered to you in no time with safely packed and vacuum-sealed packaging. Prototype the easy way with PCBWay. Quality, integrity, reliability. Thank you, PCBWay. Let's start with the schematic. So we've got the processor section, which is there's two of them. One is ESP32, W room 32. That will be generating the signal. We've got a few support components here. Selected between 24, 25 and 30 frames per second. That's a timecode output, and this is clock and data. So we've got our Atmega 328P-AU. Again, this is with a 16 megahertz crystal, and this is going to be driving the Max 7219 display driver. And then we've got our displays ELD 4265YGWA. Double displays. So again, we've got hours, minutes, seconds and frames. So that's explained. The process is now explained. Obviously the support components I'm not explaining, they're self-explanatory. We've got the LEDs here, so Max 7219 CWG. We've got support components. This is the current adjustment for the LCD displays, for the LED 7-segment displays. We've got 3 LEDs here with 1K resistor, which is a divider. I will show you that in a second. What I've done is this sort of a divider. It's 3D printed with just 2mm LEDs. There is 2 of them in there, and they just coupled together in series, and 2 pins are sticking out. I've got to have to clean this off, and that's it. And you can, again, the 3D print is done included in the file, so you can print this out, and I usually mark the positive side so I know that this is the positive when I put it on board, and that's the dividers. If you don't want this, you can just put an LED there, and that's absolutely fine. If you wanted dots dividing your screens, then that's those 3 LEDs. So that's explained. We've got a charger section with a standard micro USB. I don't know why it says mini, it's micro. That's a charger section. We've got red, green LED and the typical TP4056 chip with the 2 current monitoring resistors here. We've got also low battery warning circuit board, little device here that will light up red LED when the battery is low, which need to be adjusted. I've used this time UMH3N transistor package, so it's just a 6-pin little package. This way it reduces components, and a little voltage regulator, little trim pod that to adjust the sensitivity. We've got a switch with selector 24, 25, 30 frames and 3 LEDs to indicate which position the switch is in. Then we've got a timecode inverter, which is takes the timecode. That's the also output, and that inverts it for the logic to work on the displays. So it inverts pretty much positive to negative signal. Then we've got the power supply left. We've got the charger, clock section. Forgot the clock section. So the clock section is standard DS3231M. A few support components here. We've got a reset switch, which is connected to all of the ICs. We've got also the battery here, and it depends on what you're using. I've got CR2032 that you can do rechargeable. So if you are using CR2032 lithium rechargeable one, that resistor R23 will be 200 ohm. That's for lithium. If you're using not rechargeable one, do not install the resistor or the diode. You don't want it to be charged and explode. So that's only if you're putting a rechargeable. If you're putting nickel cadmium battery, then you add 82 ohm resistor here, which is what I'm going to be using. I've got one here, that green one. So that's this covered, and let's have a look at the power supply section. We've got standard power supply that I use textbook pretty much for all of it, all of my circuit boards. So we've got lithium battery switch, we've got the MT3608 boost converter that steps at 3.7 volts to 6 volts. Then we've got a 5 and 3 volts voltage regulator. So 5 volts is for this, for max, and for at mega, and 3 volts is for ESPW room. That's it for schematics. So let's have a look at the beautiful circuit board that we have right here. I've also printed the 3D case, a 3D printed case for it. So that's going to be the timecode generator. Again, the files for it is available, so you can download it yourself. It's going to hold the 18650 battery. This is just a standard 1/4 inch, I believe it is, screw, so you can mount it to your camera or any other equipment. This is going to be the frame selector. They throw in 24, 25 or 30. Power switch. This is going to be the BNC jack. This is the USB charger, and all the LEDs and everything is going to be on top. I've also cut the top out of Perspex. There we go, and that's going to be just snapped on the top of it and laminated with vinyl, so we'll have a nice display and everything. I'll show you that further down the track. This is the circuit board with 4 7-segment displays, dual 7 segments. We've got all the circuitry up here, the Atmega. It looks very beautiful. That's the space for the battery, so you can fit any battery here. Yeah, that's the switch. What else can I tell you about this? Again, the BNC jack. The only thing I was going to mention, there's 3 LEDs here as well to indicate which frame rate do you have. So there's 2 switches, 2 reset switches. The reason for 2, I'm going to have 2 buttons and they connected in series. So in case you, it's a safety feature, so you don't accidentally press and reset it. So to reset it, you have to press them 2 at the same time. This will reset it. But if you press 1, nothing will happen, either one. This is, so you don't accidentally bump it. Alright, so I'm gonna get all the components laid out, and let's start assembling it. Now this is done. I think it is time for me to clean up all the flux from manual soldering, add some shrink tubes that are going to go onto the LEDs. This way they don't spread the light, so I'll do that. And then it'll be time for a first power on test and see how it performs. So let me just clean it up and put the shrink tubing on, and we'll plug it in, and then we'll calibrate the battery, low-level battery indicator. Okay, so this is ready. I've applied a PCB lacquer to most of the components, and to the crucial ones like ICs, I've applied that special silicone glue. It's really hard to see on the camera, but you can see it's very clear. So everything's assembled and sealed. Batteries installed. So next step is to adjust the voltage of that LED. So we're going to connect a power supply, and we're going to supply, how do I clip it? There we go. We're going to supply 3.2 volts. I also need a switch, which I'm going to have to use this one. There we go. So just connect ground. Let's see if it'll turn on. And there we go. Timecode's running. That's a reset. Let's see if that works. It's not supposed to reset the timecode, it just resets the whole unit just in case if there's any problems. Yep. And returns back to normal timecode. So that's a selector switch, 30 frames, 25, 24. That works as well. What else is there? It already shows a flat battery, so we need to adjust it. So 3.2 is when it's supposed to come on. So we're just going to grab a small screwdriver, if I have one somewhere. There it is. And that pot on the back, the blue one that you saw, let me see if I can flip it over. This one here, we're just going to adjust it until it starts dimming. Okay, so that's on max range. Let's increase the voltage to, there we go, 4.4 volts, and it's just starting to glow. 3.5, sorry, and it's normal. And if we go to full voltage, like 3.7, 3.8, it's completely out. So let me just decrease the voltage. And as you see, as the voltage gets lower, it shows that the battery gets flat. So that's good. Okay, let's install this into the enclosure. I'm going to disconnect this. We're going to connect the battery, make sure it works with the battery. Yep, timecode's running fine with the battery. So I'm going to install that in. First, you're going to have to install the switch, which is this one. So front is installed. I've added a little thing so it looks pretty. Install the switch, put it in, then slide it to the right where the charging port is, and then put it on top of the, on top of the B and C port. So I'm going to tuck all the cables away and see if we can do that right now. So I'm going to insert the switch first. Yep. Now it's loose in there. Now we're going to insert the charging port. Oh no, the glue is still setting. There we go, the charging port's in. And now we're going to get this in. There we go. And I think it's not pushing in, there's a cable stuck in there. There must be. So I'm going to have to sort it out. So let me get the cable in the right way so it's not in the way of the board. And then I'll show you when it's in that box already and soldered. Okay, so that has been assembled. As you can see, it's a nice box with a charging port, and actually we haven't checked the charging. Let's do that. Should go, yep. So that's working. So the bottom one will be red when it's charging and green when it's fully charged, and the top red is the one that indicates the battery is going flat. So it'll start dull and then gets brighter and brighter as the battery goes flatter and flatter. that is our timecode output. We've got a switch here for selecting 24, 25 and 30 frames. So let's see how that works, and a little screw to mount the device. So that is working good, timecode's running, and let's select different frame rates, and that's working as well. And it's good because you can't easily switch that switch, so you need a nail or something. It's just recessed here, as you can see. It's pretty much flush with it, so you need a nail to select your format. Let's try reset. Yep, that's working fine. And again, you need one of them, won't do anything. You need to press both of them at the same time. So that's good. Alright, let's move on to, and the switch is here, let's move on to the next part, which is glass. So I am going to, I've already marked, as you can see with the dots, that's going to snap on and sit in a little curve there. So you can just see there in the reflection, it won't go, it's just flush with the top. So it won't go any further, and it's very snug. So being 3D printed, you have this material like a vinyl almost, as in grooves. So when that snaps in, it's going to sit there firmly. I've already marked the dots where everything's supposed to be, as you can see here. So there's 3 dots for the LEDs, where display is going to be, the dots for those LEDs, if I align it properly. The reset button, I have to probably mark it a bit more. The reset button dots, and I'm going to drill out the reset once. I'm going to drill out all the way through this frame selector switch, select LEDs. But those ones for the power and the charging, I'm going to drill halfway through because they're not poking all the way out, and I'm going to let it be sealed. So I'm going to design now the plotter material, because I'm going to print it out of vinyl and just laminate it with that. And this side I'm going to laminate with window tint. So this will give us a nice tint, so the display is only visible when it's on. Let me design this, and then I'll come back and we'll laminate it and test and assemble it fully together. You can add a little bit of glue, by the way, around the perimeter to glue that in if you want to. So yeah, let me design this first. I've got everything ready here. I've done some plotting, so I've got an overlay. It's hard to see there, but there is lettering and everything here because it's white. I've got the back of it, and I've got the front of it. So I'm going to start laminating the back by the markers that I've marked on the front on the opposite side. So once I peel this plastic off, I'll be able to line it up, which is this way, and stick it on. Once that's lined up and stuck, I can then flip it, and using the guides from the back, stick the front, and followed by the overlay. So I'm going to do this, and also don't forget the tint. I'm going to do this off camera because it's a very tricky and precise job, and it's going to take me quite a few minutes to do. And once I laminate it all, I will come back and we'll have a look at the glass. Alright, so this has been done. As you can see, it looks pretty cool. So this is just a vinyl that I've done on the plotter. Let's see if the charger is on. Well, if it's working, which it will be. There we go, we've got a red light for charging, and it'll go green when it's fully charged. The battery light will go red if the battery is running too low. Let's turn it on. And here we go. Works just fine, showing 25 frames a second. We'll press reset. And yeah. So this is it. I hope you enjoyed it. All the files to build this is down below. Don't forget to like, share and subscribe. If you'd like to support me, I do have Patreon at Max Electronics. My name is Max. I will see you next time. Bye.